It's my pleasure to be back at Tide. I guess this is my fourth Tide conference. I've been extremely privileged to be a part of this journey, working along with the team at DigitalOcean from the time they started in India. So what an exciting time to be in technology. And I particularly liked Hemant's presentation. It actually gave a pretty positive, optimistic look of being a technologist, and that too, particularly being a part of the India developer ecosystem. So I've been in the industry for about 20 years, predominantly spent the time at Microsoft and Amazon, and in the roles of selling technology. Today, when I look at the landscape, when I look at the industry, within India, across the globe, it's very fascinating. Most of you would be very young. You wouldn't have seen the evolution and the transformation of technology over the last 2 decades, but I've been fortunate enough to be a part of that and watch it from close quarters. So I want to give you a perspective on how the entire industry has transitioned from using technology to contributing to technology and participating in the overall revolution that is leading us to the next gen modern applications and modern infrastructure, which is now called as cloud native computing. So 20 years ago, when I started as a sales intern at Microsoft, I had the opportunity and I had the fortune to sell to large companies. I went to Mahindra & Mahindra, Maruti Suzuki, BHEL, NIC, various public sector companies. At that time, technology was all about consumption. IT was all about running desktop software and some set of servers in the corner of the building. Fast forward to 2015, 2018, and 2020, technology is no more just about consumption. Today, if you look at the large bank or a healthcare organization or even an educational institute, they are not just consumers of technology. They are producing technology. They are contributing to the overall technology revolution. And that actually blurred the line between a high-tech company and an enterprise technology company or enterprise company in any vertical. So interestingly, today, there are no more IT departments that are confined to a set of people sitting in a corner and driving the desktops or supply chain management or server management. Every company is actually becoming a hardcore IT and technology company. And technology is no more just an enabler, but it is a part and parcel of the overall business. The role of a CIO, CTO, and CDO are more important than ever. I want to give you some examples. If you actually look at these headlines, they convey a lot of behind-the-scenes story. Tesla has changed the face of automobile industry. They forced the incumbents like Ford, General Motors, Toyota to look at technology from a very different lens. Tesla is more of a software company that also does auto. And every Tesla that is being driven out there is actually an edge computer on the roads with 4 wheels. It's a massive AI-enabled edge computing device, which you can drive. And that is how Tesla has kind of changed the game, and it has become more of a hardcore tech company with a flavor of automobile. Same thing with Airbnb. If you take the technology element away from Airbnb, there is nothing left. Airbnb doesn't own any real estate, any property, but they still connect a lot of dots. They basically do a matchmaking of potential travelers and hosts who are looking at renting out a part of their property. And I have been a big user of Airbnb, and I absolutely loved it. When I travel to Bay Area, I rely on Airbnb for what they do. Without that, I wouldn't be able to afford just staying for a couple of days there. So Airbnb is bringing technology to hospitality and the hotel industry. Same thing with Netflix. Right? Netflix is an amazing tech company which also does video streaming. And if you look back at their contributions to the overall open source and a variety of technology stacks, they have been at the front and center of the latest modern cloud technologies. So much so that one of the chief architects at Netflix, Adrian Cockcroft, has been hired by Amazon, and he is now the chief open source advocate at Amazon, driving the AWS open source paradigm and the entire open source initiative at AWS. And of course, the whole e-commerce industry is threatening the traditional supply chain and the traditional retail. And every retailer is now thinking on how to use technology. And finally, what else is left in terms of transportation other than Uber and Lyft, right? And then, of course, our own homegrown Ola. So if you look at the way technology is being applied, the traditional, the haggling with the auto drivers and getting frustrated is, I haven't seen that in the last 1.5 to 2 years. Even my mom, who is not very tech savvy, relies so much on Uber and Ola that she can actually book a cab and travel all by herself. And that is the power of technology reaching the last mile and benefiting the consumer who is not really a tech savvy person. There is one thing common across these examples. Now, they are just not application of technology or bringing technology to the consumer. All of them are hardcore contributors to technology. And the line between consuming technology and contributing to technology is completely blurred. Every company is now a high-tech technology company, not just running a bunch of servers and desktops, but actively contributing to the open source momentum. So software is becoming the key differentiator. What was once just confined to enabling and accelerating business and impacting the bottom line is now the bottom line. If you look at every automobile company, every healthcare company, everyone is spending the same amount of R&D budget like a high-tech company that has spent during the late 90s or early 2000s. Everyone is looking at how can they consume and adopt the most cutting-edge technology that is going to help them become almost as competitive as a very young startup, which is actually at the forefront of consuming and contributing to technology. So if you actually look at the spectrum, there are very young startups, and they are cloud-born, digital-born companies who rely exclusively and extensively on the cloud. They don't even have a receptionist. They don't even have any server running in their office. Everything is in the cloud. They subscribe to SaaS, they subscribe to IaaS and PaaS. And then you have an enterprise, which is running a lot of traditional infrastructure in the massive data centers. There was a time when the startups were very nimble, very agile, very young, very risk-taking, and they could actually become a threat to a lot of traditional incumbent enterprises. But today, enterprises are not sitting quiet. Enterprises, small and medium businesses and startups are embracing technology almost at the same pace. When I was selling Microsoft, the biggest sales pitch for us was, oh, don't go to open source. And I'm talking about late 90s and very early 2000s. Don't go to open source because you don't have a neck to choke. If something goes wrong, you cannot go and post it on a community forum. And at that time, there was no GitHub, there was no Stack Overflow, and there were some Yahoo chat rooms supported by hackers and open source enthusiasts. And enterprises never ran like that. So when Microsoft, Oracle, and IBM, very proprietary companies, sold software for millions of dollars, their pitch was, don't embrace open source because there is no single neck to choke. If something goes wrong, you don't have an account manager to call, right? And today, the same companies that actually threaten customers not to buy open source are in the thick of action. Example, Microsoft buying GitHub, right? IBM buying Red Hat. And wait and watch, in the next 2 years, we're going to see a lot of consolidation. The top 5 companies are going to buy a lot of software, open source software companies to get onto the level playing field. So software has become the biggest differentiator. If an enterprise can embrace software at a rapid pace, they can compete with a very young, nimble, agile startup. So the only secret to being agile, effective, productive, and efficient in this era is to be a very active contributor. Remember, it's even contribution, not just consumption. Contribution and consumption of software. And this is becoming the biggest differentiator. I want to borrow a quote from John Chambers of Cisco Systems, right? 40% of businesses will die in next 10 years if they don't figure out how to embrace the latest technologies. And this is so much true. I really don't know when he said, but there are so many examples of how Fortune 500 companies that existed for more than 2 centuries are at the brink of dying down because they're not able to embrace cutting-edge software and make software as their key differentiator. And this is not to threaten, but this is a clear indicator on how software is becoming and technology is becoming the biggest differentiating factor. So, for small and medium businesses, for enterprises, or anyone who is in the business of serving customers, digital transformation is big. And digital transformation is an umbrella term. You ask a CDO, a Chief Digital Officer at an enterprise, or you ask a very half CMO slash product manager in a tiny startup with just 6 people on what is digital transformation, you get a very different answer. But digital transformation is a nice marketing term that is coined to basically bring everything under the technology umbrella. And there are 3 key pillars to getting onto this new paradigm of digital transformation. The first one is open source software. I mentioned some examples on how open source is becoming the key pillar. And then cloud. Cloud has changed the game. More on that a little later. And then data and analytics. I can tell you with a lot of confidence and proof points that any company that figures out how to effectively embrace these 3 pillars are going to have tremendous impact in their own field, in their own vertical, and they're going to have the biggest customer satisfaction numbers. Now, there is an interesting correlation and relationship between these 3 pillars. Open source software, it's everywhere. And today, proprietary software is almost at the brink of becoming extinct. Oracle is threatened by MySQL and Postgres. Right? The development tools, Visual Studio, Microsoft is actually pushing more of Visual Studio Code, which is an open source IDE. And the whole AI and ML momentum is around open source, from Python to NumPy to Pandas to TensorFlow to Caffe. Guess what? Every element of AI and ML is out there. It's in open source world. So when open source is available to everyone, from each of us to the key researcher in Stanford, how can companies differentiate? How can they deliver more value? Because it's the same piece of software that's available to you, available to me, and available to any other Fortune 100 enterprises and software platform companies. That's where cloud comes in. And cloud is now the software delivery vehicle. So you have open source software that you can consume directly, but the experience matters. The reliability matters. That's exactly where the focus has shifted. Now, if you take an open source technology like Kubernetes, every cloud vendor is getting onto the Kubernetes bandwagon. Today there are 27 hosted Kubernetes managed platforms, from Google to Microsoft to Amazon to DigitalOcean to Alibaba to Huawei to there are umpteen number of managed service offerings. Guess what? All of them consume the upstream Kubernetes distribution straight from GitHub. So what matters? Well, what matters is simplicity, right? What matters is reliability. What matters is the developer experience. That's where the battleground is. And that's where I love DigitalOcean. They absolutely focus on those pivots that make open source very developer friendly and very consumable. And that's where the world is shifting. Today, if you actually look at the cloud landscape from a distance, if you zoom out, everyone is delivering exactly the same set of services and based on same set of open source software. But the overall delivery of that software through the cloud matters a lot, and it is game changing. Then comes in data and analytics. Now, enterprises have tremendous amount of data, which they haven't been able to tap. For a long, long time, they have been collecting data that is actually rotten in data warehouses, business intelligence servers, and a lot of tapes and DVDs and traditional storage medium. They never knew what to do with it because computing was not affordable. Computing was never cheap. Storage was never cheap. So if you want to pick a data set 5 years ago, someone has to walk into the backup and archive room, look at their catalog, look at the index, pull out the tape cartridge that has a date on it, insert it, wait for the cartridge to get loaded, and then access it, and then feed it into their existing business intelligence dashboard, and then spend another 2 weeks to basically bring in the correlation between 5 years old data point and the latest data point. Now, this is not agility. This is not what is going to help customers. Now, fast forward to 2020, you don't have anything locked and leashed inside the captive data center. Everything is out there in the cloud. There is object storage that is becoming absolutely affordable and cheap to an extent that it would just cost a dime per GB. It's like extremely cheap. So you don't have a reason not to store data in the cloud. You don't have a reason not to access it on demand. So when you have abundant storage and you have affordable, abundant, high-performance computing, you are going to get a lot of insights. That's what is data and analytics. And the foundation for this is, of course, cloud. So the 3 imperatives for business of any size, it doesn't matter whether you are a startup of 5 people or a small and medium business or a large enterprise. There are 3 imperatives for you. Consider open source. Consume cloud. Move the heavy lifting and undifferentiated heavy lifting factor to someone else, and you focus on your core business. And don't underestimate the power of data and analytics. Tap into it. Those are the 3 pillars. Now, if we look at the data platform evolution, it's pretty fascinating. It all started with RDBMS in 80s, Ingress, Informix, Oracle, and so on. Then there were 4 GLs. That's when I encountered databases, FoxPro, DBase 3+, and so on. And then came in data warehouse, Cognos, Oracle, SQL Server. And then in 2015, the NoSQL became mainstream, MongoDB, Cassandra, and HDFS, HBase, and so on. And in 2020, we are going to see distributed databases. And these distributed databases are running at the planet scale. So you insert a record in Tokyo, it becomes available in San Francisco in a few seconds. And it is not eventually consistent. It is consistent the moment it is written. And there is a lot of research going on in how to build planet scale, consistent databases. And this is going to be game-changing for a lot of industries. This is the next generation of data platforms. You never own a server, you never own a database, but you're going to tap into a fabric that cuts across the globe. And there is a lot of innovation happening in that space. So that is the evolution of data platforms. When it comes to app platforms, code typically ran inside mainframes initially in 70s. And then all of us have experience with client server. Oracle with Forms 2000, VB with SQL, Power Builder with Sybase. I have been through that journey myself. And then we have seen web services and SOA in 2000 and 2005. And then came in PaaS. Google launched App Engine in 2009. And then came in Heroku, EngineYard, and a set of platform as a service offerings. And that started to change the game. Interestingly, cloud revolution was not initiated by IaaS, as most of us think, but it was PaaS that actually triggered the entire revolution. And it was nothing short of magic to write code and run it in a remote data center and watching it scale. And that was a true game changer for developers. Then came in IaaS, pushing a button, launching a VM, and the ability to SSH into that VM as root, and you being in the driver's seat of that VM was amazing. People were only used to GoDaddy-style hosting with a cPanel and pushing buttons and raising support tickets. And from there to launching VMs and managing a fleet through script was fascinating. And that was IaaS. And now we are at the verge of embracing the next big paradigm, which is CaaS, Containers as a Service. And this is the next generation modern infrastructure, which will give you that last bit of performance from your VMs and infrastructure. And Containers as a Service is huge, it's big. It is actually taking over the world by storm. And then going forward, we are going to experience more of FaaS, Functions as a Service, because we are living in an event-driven world. So you book an Uber, the Uber comes, you get a notification, and there are 100 events that get generated from the time you choose your location, from the time you end the trip. And those events are very, very powerful if they're actually consumed and stored and analyzed. So instead of running code that is running forever, whether there is a request or not, we are going to move into a world which is event-driven. Your code will not be running forever, but it gets invoked only when there is an event. And a cascading chain of events will invoke a set of functions, and they all work in tandem to deliver a very powerful functionality. And that is going to be FaaS, functions as a service. And there's a lot of work going on in this world with the standards like OpenFaaS and Knative that are emerging. And finally, when it comes to infrastructure, it's again mainframe to physical x86 servers from HP, Dell, Compaq, IBM. We have been seeing them, and they also doubled up as room heaters for a while. And from there, we have seen virtualization, KVM, Xen, Hyper-V, vSphere. And then we have seen the infrastructure move away from hypervisors to more of container runtimes. And today we are talking about Runc, Containerd, which have strong roots in LXD and Linux containerization technology. And eventually we are going to see serverless becoming a part of core infrastructure. And this is already visible today, when you actually run Kafka, when you run Spark, and when you run event-driven infrastructure, even servers and containers get provisioned when there is an event, and they die when the execution is done. So the serverless momentum, which by the way works hand in glove with the application services that I talked about, is the layer that basically powers the underlying infrastructure for this. Now, zooming on to containers a little bit. Interestingly, we as software industry are experiencing the same challenge of the logistics industry of 1960s. In 1960, it was very, very difficult to port goods from one point to another. And it was very difficult to isolate one class of goods from the other class. For example, coffee beans, right? Porting coffee beans from one location to another, from Ethiopia to, let's say, China, was very hard, because when you mix and match coffee beans with strong pungent spices, it would start influencing each other, and then it just becomes useless. Similarly, porting brewery equipment and draught beer from one location to another, along with automobiles, was very risky. Now, what happens if the beer spills over into expensive automobiles and they get damaged? So it was very hard. So there was no isolation, and there was no unit of portability. So eventually, the whole industry agreed upon a standard, and that was container. And today, we see containers everywhere, right? When Hyundai ships their cars from Korea to Bangalore, it comes on a container. And when you relocate from one city to another, you negotiate with your packers and movers in terms of containers. And it has become a true standard. And they also bring tremendous isolation. Automobile vendors put multiple cars in one container. Coffee bean vendors hire one full container and dump all their coffee beans into that. So it brought in tremendous isolation. It brought in tremendous portability to an extent that the trucks, the ships, trains, cranes, and last mile delivery mediums, all of them started to refactor and redesign themselves to accommodate containers. And the whole world has changed. It's no more the same. Now, interestingly, software development is not very different. If you are a developer, you know what I'm actually talking about. Today, we don't have the luxury of coding on Microsoft stack or Java stack, right? There was a time when you could proudly claim to be a .NET developer or a Java developer, and it was game over, right? You wouldn't be ever questioned about a Microsoft technology if you claim to be a Java developer. And if you belong to the Sun camp, you hated Microsoft and Windows NT, right? I come from that world. Now, today, the lines are blurred. Today, an application is composed of a variety of diverse technologies. Your static website is written on Nginx and Bootstrap or React.js. Your background workers are written using Celery, Python, or Node.js. Your web frontend is written using Ruby on Rails with Unicorn framework. Your profile database is using Postgres. Your analytics is being stored in HBase. Your graph database is Neo4j. And you have a NoSQL database as MongoDB. And then you expose your API endpoint through Nginx reverse proxy. This is a pretty complex matrix. That's not all. Now you got to make it work on your laptop, in your company's data center, in virtual machines, in a colo environment, in the public cloud, and ultimately in containers. Now when you make sure that your code is running in all these environments, it's actually a matrix of hell. And that's when we hear this utterance, oh, it works on my machine, right? If you're a developer and if you haven't uttered this, you are not a developer, right? Every developer in his career at some point would have uttered these magical words, oh, it worked on my machine. Particularly when you are showing a demo to your manager, to your client, or you are actually showing it in front of audience like me in an event, and you are going to utter these words. And this is bound to happen because what works on one environment may not work in another. Fortunately, containers come to our rescue, right? Like the cargo industry, we are going to tremendously benefit from containers. They offer lightweight virtualization. They are the standard packaging and deployment format. They deliver tremendous isolation, tremendous portability, and you can ship software more often, and it has become a standard unit of deployment. So this is definitely not a crash course on containers. No, I have a demo on Kubernetes with managed Kubernetes on DigitalOcean in the afternoon. I'm going to do a deep dive on that, but just to give you a sense of the correlation between containers and Kubernetes. So containers are these tiny units that run one piece of a code at a time, but you need a manager, an orchestration manager, a coordinator, a master to manage these tens of thousands of containers that are running on hundreds of machines. And managing those tiny containers all by yourself with hand-woven scripts is a pain. So you need someone who can actually manage it in a very efficient form. And guess what? Kubernetes is that software which is managing these containers. And it is basically the open source orchestration manager that has become a de facto gold standard for managing containers at scale. And this is the foundation of what we call as cloud-native technologies. And cloud-native technologies going forward would actually run on top of a cloud infrastructure, utilize distributed databases. They are based on Kubernetes, and you're going to run microservices on top of it. So I have taken you through a journey, right? I spoke about how software is becoming a key differentiating factor. Then I spoke about three things: open source, cloud, and analytics. And now we are actually focused more on cloud and zooming on to it in terms of how we embrace the next wave of cloud computing, which is called cloud native computing. So cloud native computing has four different pillars. The first one is it has efficient DevOps. So DevOps, the meaning is again very broad. If you ask every DevOps engineer, he's bound to give you a different answer. But DevOps is basically making sure that developers and operators live in harmony and peace and don't fight with each other. It's a lot to do with culture. It's a lot to do with the tools that you adopt. It's a lot to do with the processes that you embrace. Doing DevOps with virtual machines is what we do today, but it's not very efficient. There is this whole new evolution of DevOps into the next phase called SRE, Site Reliability Engineering, observability. And that is enabling customers to get the best out of their infrastructure investment. DevOps or observability or SRE will ultimately give you highest available uptime, right? So you're going to get those 99.999% uptime when you follow DevOps and SRE for cloud native. And cloud native just makes it very easy for you to implement those technologies and those mechanisms to derive the best from it. Continuous delivery. Today, as I mentioned, every company is a software company. And the largest software companies like Amazon, like eBay, they ship software not just once in a day or once in a week. They actually ship software almost every hour, right? And they do that almost in a factory style. And the supply chain for that factory is called the CI/CD pipeline, the continuous integration and continuous delivery pipeline. And they connect a variety of dots in that pipeline, all the way from source code control till the Artifactory where the images are stored, and Kubernetes where it actually gets delivered. And the CI/CD pipeline is super critical for you to get the best out of your cloud. And when you package your code into images, container images, and deploy them on Kubernetes, scale them, and do things like canary releases, red-black deployments, you are essentially using continuous delivery techniques. And again, you can do that with VMs, but containers make it more efficient. And then microservices. So microservices is a paradigm. It's a pattern. It's a design pattern where you package and deploy code as tiny, fine-grained pieces of code that do one thing at a time. And you assemble multiple autonomous microservices into one application, and you can independently scale, manage, and upgrade each of those microservices. And one microservice doesn't know that there is another microservice that exists. They all live in very isolated, in a very autonomous form. But when you connect the dots and bring all of them together and orchestrate them through Kubernetes, you have a phenomenal application. And that is the modern application delivered via containers and microservices. So microservices is not really a technology. It's a pattern. It's a design pattern for you to adopt to get the best out of cloud. And finally, containers, the smallest unit of packaging and deployment. So when you bring all of them together, when you target cloud, what you essentially have is a cloud-native computing. And what benefits does it deliver? First thing is optimal resource utilization. So when you're running VMs, the average utilization is 55%, 60%. That's because one server is running at the brim, the other one is lying idle. With cloud native, you don't deal with one VM at a time, but you create a pool of resources, and Kubernetes, which is the master of that pool, will effectively optimize your infrastructure. And it can balance out your idle resources and heavily utilized resources to give you a baseline performance. And that is the biggest advantage, because your infrastructure bill will be down by 40 to 50% if you do it really well. And then rapid software delivery. Now, as I said, this is a factory model where your supply chain is actually constantly running, and all the way from the developer committing his code to Git till it shows up to the end user, you can automate that and you can ship software at a very lightning speed, and that is rapid software delivery. Ultimately, faster time to market. Today, if you have an idea, thanks to cloud, thanks to open source, thanks to cloud native, you can take it to the customer in the shortest possible time window. And you don't need to spend millions of dollars to even realize that. You can actually pull in open source, pull in cloud, subscribe to a service like DigitalOcean, which is extremely affordable, and then quickly prototype and take it to a set of customers and try it out. And you can actually iterate over it using cloud native, CI/CD, and DevOps, and you can improvise every time you have a new feature or a feedback from the customer. That's what is closed loop feedback. You know, when a customer comes back and reports something, you're not going to issue a hot fix or a patch. You know, those days are gone. Now, the developer team will immediately fix it, will commit the code, and boom, it shows up to the end user in almost no time. And these are the benefits of embracing the second wave of cloud, which is cloud native. So that brings us towards the end of this session. And I want to summarize what I mentioned. Digital transformation is a broad term, but there are three pillars: open source, cloud, and data plus analytics. And the focus for today was cloud. So I spoke to you about how the cloud platform data and infrastructure have been evolving over a period of time, and how containers and Kubernetes are taking the key role in this transformation, and how they deliver the next wave of computing, which is called cloud native computing. If you are interested in seeing a hands-on demo, scaling and deploying microservices, I have a session at 2:30 where I'm going to do a deep dive on deploying Kubernetes and scaling. So I'm going to see you there if you are interested, and we'll continue the discussion. Thank you.